Well, thank you for joining me. I'm going to be looking at question 3, part B. I've already done 3 part A, and we got an answer of the speed of 8.83 meters per second. But we're now after Arun's height above the water when he's traveling at 11.1 meters per second. So let's just recap the story. At an annual Birdman competition, Arun dresses up for a wingsuit, jumps off the edge of the cliff at 30 degrees to the horizontal at 5 meters per second into the water 6 meters below. There's the diagram there. Unfortunately, the suit is poorly designed, and rather than gliding, he falls with a negligible air resistance on a parabolic trajectory. Use conservation of energy methods to calculate. Now, part B says Arun's height above the water when he's traveling at 11.1 meters per second. Well, let's have a look at 11.1 meters per second. He's traveling at 11.1 meters per second. Is that it? 11.1. The thing is, there's a vertical and a horizontal component here, and because we've already established the horizontal component, we already know that it is 5 cos 30, and that doesn't change because the acceleration is 0 in the horizontal. So let's look at this vertical component and find out how long it takes us so that we could get the point. The vertical component will be using Pythagoras. 11.1 squared equals 5 cos 30 squared plus that v squared. So we've got v is the square root of 11.1 squared minus 5 cos 30 squared, and let's do that calculation. So 11.1 squared minus 5 times cos 30 and square that is 18.75, and minus 123.21 is 104.46. So that is meters per second, and so we're dealing with UVAST. We've got our 5 cos 30 degrees. We know our acceleration is negative 9.8 meters per second squared. We've figured out our vertical is negative 104.46. We already knew our horizontal. So let's just put horizontal title here, vertical here, vertical component. What we're after now is how long, what are we after? When it happens, is that right? Are we after the time? No, we're after S. Okay, so we're after S. Now, we knew that the initial velocity is we're after not S, we're after the height. Okay. Yeah, our displacement. So we knew this was 5 sine 30 in the vertical, and now we want S. So S, we could have S equals UT plus half AT squared. We don't know T. We could have V squared equals U squared plus 2AS. Yeah, that formula doesn't have t in it. So the other one was v equals u plus at. So let's use this equation here. V squared, so we've got square 104.46 equals u squared, which is 5 sine 30 squared, plus 2 times negative 9.8 times s, and that's what we want. So we'll bring the negative across to be positive, so that becomes 2 times 9.8 is 19.6 s, and 5 sine 30 squared minus, and when we square that, that becomes 104.46. And let us divide our numerator, divided by 19.6 to get our s. So let's put that in a calculator. So we've got 5 times sine of 30, and that's 6.25, minus 104.46, and divide that by 19.6, we get, divide it by 19.6, enter that correctly here. We get negative 5.0107 meters. So we are how far above the water? Well, if it's 5.01 meters below, 5.01 meters below the launch pad, and it's 6 meters to the water, therefore it is only 0.99 meters above the water. Okay, I hope this has helped. Until next time, stay happy.